Okay, so today we're on page 5B, Solving Equations 101. I'm just going to do a quick review of the notes and the terminology to help us when solving equations again. So an equation in math is a math sentence that includes an equal sign. Versus if there's no equal sign, we'd call that an expression. So we've already done this terminology this year. This is a little bit of a review. So if I have 3x, that 3 we call our numerical coefficient. And that really means 3 multiplied by x. There's that sneaky multiplication. The x is our variable. The 4 is our constant. And the -2 you might call your solution or also your constant. Depends on the context. So the goal of solving an equation is to find the value of our variable or that unknown piece. To do that, we isolate the variable on one side of the equation using opposite operations. So let's review what opposite operations means. So I'm going to do the opposite of addition. Our opposite of that is subtraction. Opposite of subtraction is addition. Opposite of multiplication would be division. Opposite of division is then multiplication. So you're using this opposite operation in order to cancel that operation out to get x by itself. So I have a diagram here of a scale. So this scale has an x and 3 ones on this side. So I could say x plus 3 is equal to 1, 2, 3, 4, 5, 6, 7. And those two sides are balanced. So that key word is balance. You might also see equivalent. But what it's getting at is this x plus 3 is equivalent in value to the 7 ones. So they're equal to each other. And that's why it's so important that whatever we do to one side of the equation, you have to do the other to keep our scale balanced. So algebra tiles is something you might have used last year. It's a visual to kind of help us solve. So they each represent something. So the long skinny rectangles represent our variable, most often x, and then we have ones tiles to represent our ones. So when you're working with algebra tiles, you have manipulatives in front of you. If I have 3 ones on the left side here, to cancel out those 3 ones, I would add 3 negative ones. So I'm just going to draw a negative. They're usually color-coded for you. These ones are green and yellow, for example. They will vary. A positive 1 and a negative 1 equals 0. So that means this group cancels out. This group cancels out. This group cancels out. Cancels, 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 right? +1 minus 1 is equal to 0. So that cancels out. So I have a single x left on this side with 6, 7 ones on my other side. X equals 7. And that makes sense. If I was to write this one out, I would have x, I would have x plus 3 equals 10. If I replace that x with a 7, well, 7 plus 3 equals 10. So I'd write that out. Let me show you with our notation. So I added 3 negatives, add 3 negatives. Those cancel. Well, 10 minus 3 is our 7. So that's your notation for your algebra tiles. Slightly different when your tiles are like this. So I have 2 x's and I have 6 ones. Well, division means how many groups. So in this one, I could match 1 x tile with 3 ones tiles. So how many you can match with a single x? So in this case, x is equal to 3. Using our notation, I would divide both sides by 2. 6 divided by 2 is 3. So remember, division means groups of. So I have 2 groups of 3, meaning in each group, I have an x tile and 3 ones tiles. Okay. So what's really important in algebra is our notation. We always want to work vertically down the page. You want your equal signs there. So this is also an example of how you can show your notation. So let's go through a couple of these with the checks. So the first example says x plus 2 equals 10. So we want to cancel out the plus 2. So the opposite of adding 2 is subtracting 2. Plus 2 minus 2 gives us this 0. 10 minus 2 is 8. My apologies. So then I would get x equals 8 as my final answer. To do a check is you're literally plugging that 8 in. So instead of writing x, I'm going to write 8. Plus 2 equals 10. Does 8 plus 2 equal 10? Yes. 10 equals 10. That's your check. You do not always have to do a check for me. I will always specify when I want that check. Example 2, y minus 8 equals 15. The opposite of subtracting 8 is adding 8. So I'm going to get plus 8 plus 8. So this becomes 0. My 8's cancel out. 15 plus 8 gives me 23. Let's check. 23 minus 8 is 15. 15 equals 15. I'm not sure why that erased. This last example, I'm adding 9 to both sides, to my left side of my equal sign. So I'm going to subtract 9 from both sides. I apologize. So opposite of adding 9, minus 9 minus 9, that equals 0. 2 minus 9 is negative 7. So our check is negative 7 plus 9 equal to 2. Yes, 2 equals 2. If you did this wrong, so say you made a mistake and you got right here, you just wrote 7. You forgot that was negative 7. When you do your check, you would have then said 7 plus 9 equals 2. Well, 7 plus 9 is 16. Does 16 equal 2? No. You know that's not true. So then you'd go back to see if you could find your mistake. Now that we've done that little bit of review, I apologize for some of the computer errors there. You're going to go back and answer these 2 IXL links. I'm just going to click on them so you can see the letters. So the first one is x.6. And the second one is x.3. So I want you to complete both of those. And you're going to reach 80. So x.6 and x.3. Make sure you're doing the grade 8 option.